Physics 2 lab by Judge Manger. For a short introduction to this lab, we're going to use the charge tape model that we had used previously, but we're going to take the tape and divide it into many segments and treat each as a point charge, which will give us a much more accurate model of what is happening in the lab. Some of the fundamental concepts is we're going to be using same tape, same ideas, Newton's second law of motion, Coulomb's law, superposition principle for adding segments. Some of the results from our first lab, we used equations to find out that the force from the electron is 0.00196 newtons. The charge of each tape is 2.96 e to the negative 9. And then our new code that we have written should be a more accurate version of what we did to find these results previously. And then some of the models we used. Each piece of tape was modeled as several equal segments, with each segment treated as a point charge so that we can apply the properties of superposition to find a charge of each piece. Some assumptions we made: there's no air resistance. Each piece of tape has the same charge, and the charge of each piece of tape is equally distributed along the length. All of those are not technically true, but we can assume that. So in our experiment from lab 1, 2 pieces of tape, both equal in length, and we stuck a third on the desk, ripped the 2 pieces of tape off and set to the desk one by one, so they gained a charge, and then put them close to each other so that one would float. And then from lab 2, we're trying to find more accurate numbers than the ones we found in lab 1. With the new code, we should be getting more accurate values than the ones that we found in lab 1. So some of our results: the magnitude of electric force is 1.9 e to the negative 4. It's very different from what we found before. And then magnitude of gravitational force is 0.1962 newtons. So this is my diagram from the glow script. And then some of the code that we used. We have our constants. This is what we found on our first lab for finding the electric field of a particle, and then we basically add all those particles up and throw them on the diagram. And then some of the errors that we made. So there are some model discrepancies. The model we made is a much more accurate version than the one that we previously made, although it's still not a perfect measurement as we broke it into parts and we're not going atom to atom. So when we break it into big parts the way we have, the atoms, like the charge is not exactly equal throughout the whole piece that we've cut up. So it could be different. And then some errors: the tape measurements may have been off, the distance may have been off. We weren't exactly super accurate when we did those. Charges are not equally distributed, which I was saying earlier. And the charges on the 2 pieces of tape in relative to each other are not exactly the same. And so here's our what if question. So what if we had modeled each of your tapes as a single point charge? So it's not going to be as accurate at all, because we're taking the entire piece of tape and making it 1 point charge, as opposed to taking the whole tape and then making a lot of point charges along the tape. So it will not be nearly as accurate. And then why do the estimates differ? Which value is more close likely to the real value? They differ because the methods of calculation are completely different. In the calculation that we did before, we did one equation. With this one, we do that same equation, but with the small pieces, and add them all up. And so the recent model is going to be much closer to the real value because it's a lot more accurate way of finding said value.